The broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody. Good morning to some, good evening to others. Um, Welcome to the monthly GoldSim webinar. Let's just do a quick sound check. Raise the hand if you can hear me. I just want to make sure. Good. Excellent. All right. Okay, today we are going to talk about unscheduled time steps and their impact on modeling flows of material. This is a pretty simple topic, actually. It won't take long to go through it, but what we've discovered over the years, we keep track of the questions that our users ask through our help desk. This is by far the largest issue that comes up where people are confused about how GoldSim works, why do my results look different than what I expected. So we decided that this would be a good time to discuss this topic again. So we're going to talk about understanding how time stepping in general works in GoldSim. Pretty simple stuff. And we're going to introduce this concept of unscheduled updates or unscheduled time steps. And we'll talk about how they affect models. So let's dive right in. Oh, by the way, if you have any questions, let's just save them to the end and we can have questions at the end. So GoldSim steps through time in discrete intervals referred to as time steps. Everybody who uses GoldSim understands this concept. Calculations, which we refer to as updates of the model, are carried out at the end of every time step. So there's really two terms here that are often used interchangeably. I'll use them interchangeably here, and they're often used interchangeably in the documentation. But the term time step actually refers to an interval of time. The term update is the actual calculation at a point in time. So a time step is the interval of time between updates of the model. So you can imagine as we're walking through time, we have to update the model at certain times. We call these updates of the model, but we often refer to these as time steps too. But in actuality, a time step is an interval. So there's two types of updates in GoldSim. There's what we refer to as scheduled updates and unscheduled updates. So scheduled updates is what most people expect. Prior to running the model, you're going to specify when do I want, how long is my time step? When do I want these updates to occur? And you typically specify these by defining a basic step. There's some other more advanced ways to create scheduled updates. You can create reporting periods and capture times. You can have little telescoping time steps. But the key point here is, in fact, you can see a list of when these scheduled updates will occur before you run the model. The other set of updates are called unscheduled updates, and these are dynamically inserted on the fly by GoldSim in response to certain events. And what that means is you don't know when they're going to occur. GoldSim does not know when it's going to have to insert these unscheduled updates at the beginning of the simulation. And these are the type of updates that can often cause confusion, and that's what we're going to focus on today. So the first thing we would ask is, why do you have these unscheduled updates? Well, the purpose of unscheduled updates is to more accurately represent the dynamic behavior of the system. In particular, many of these events or sudden changes can occur to a system, and they're going to occur in between your scheduled time steps. Your scheduled time steps are just an artifact. There's nothing special about one day or 1 year or 1 month. It's just how you've decided to update the model. But the real world doesn't respond in terms of days and weeks and months. Things just happen, and they'll often happen. In fact, they will always happen in between your scheduled updates. So we can delay these. So let's say something happens in the middle. You have let's say a 1-day time step and something happens in the middle of the day. We can push those to the end, and we'll discuss how you can do that in GoldSim. But this can really decrease the accuracy of your simulation, and in some cases completely miss critical behavior. And as a result, unscheduled updates are on by default. We are going to produce unscheduled updates in GoldSim. So under what circumstances do we produce unscheduled updates? Well, probably the most obvious is when you define events, random events in a model. If you have a random event in a model, and we'll show an example of this shortly, it's randomly going to occur, and it's not going to occur on one of your scheduled updates. So GoldSim is going to create a new update at the time that event occurred, to more accurately represent it. Now, if you have timed events, you can also delay events. You can create a time series that kicks out events at certain times. All of those will interrupt the GoldSim and insert an unscheduled update. Another common way that unscheduled updates are created is when a reservoir or a pool reaches an upper bound or a lower bound. And this is very, very common, particularly in water management models. So in a water management model, we're going to hit an upper bound. We're not going to hit that upper bound. We're going to start overflowing, let's say, or we're going to hit a lower bound. We're going to run out of water. That's not going to happen on a scheduled update. It's going to happen somewhere in between. GoldSim is going to insert an unscheduled update to capture that point exactly. There's another important time that we create unscheduled updates, and that is in our trigger dialog. So when you trigger something to occur, there's different ways you can trigger something to occur. You may often use a trigger that says on true. When X becomes greater than Y, pull the trigger. But we have a special trigger called at stock test. An at stock test trigger, and we'll show an example of this shortly, it interrupts the clock and inserts an unscheduled update when that condition becomes true. So if you say at stock test X greater than Y, we're going to interrupt the clock and put in an unscheduled update. If you say on true X greater than Y, GoldSim is not going to interrupt the clock. It's going to wait until the next scheduled update. That's a really key point. There's a couple other triggers, at date and at e-time. For these things in which you're actually specifying a date or a time, we're going to interrupt the clock. We're going to say, well, he wants this event to happen right at this time, so we're going to interrupt the clock and insert an unscheduled update. You can also specify a dynamic time step. It's rare that people do this, but you can actually create logic in your model. If X is greater than Y, shorten the time step to 2 minutes. In those cases, we're going to obviously have to create an unscheduled update on the fly in the model. And there's a number of specialized elements in some of the GoldSim modules. For example, the reliability module simulates failures of equipment. A failure is an event. So when the piece of equipment fails, that interrupts the clock. We're going to put in an unscheduled update. Okay, the big thing about unscheduled updates that probably causes the most confusion is that by default, they do not appear in your time history plots and tables. Only scheduled updates appear. And this is intentional. So we might have a model in which we have a 1-month time step, but in between, there might be 10 unscheduled updates. But you don't really care about those unscheduled. You don't care to see when those unscheduled updates occurred. We just need to know what the water level was at month 1, month 2, month 3, month 4. So by default, these unscheduled updates do not appear in time history plots. It doesn't mean that they're not happening. It just means we're not saving them and plotting them for you. So the impact of these updates certainly occur. So we've updated the model, and that's going to change the results, but we're only plotting the outputs at the scheduled updates. We can, however, instruct GoldSim to plot these unscheduled updates, and we're going to do that today because this helps you really understand what's going on in GoldSim. So to understand this, let's look at a few examples. First, I'm going to look at a very trivial example, and this is an example in which we have a random event specified. So this is just a random event. It occurs once every 20 days and occurs randomly. So it's not going to occur on my time step. My time step, by the way, is 1 day. So I have a 1-day time step. I'm going to simulate the model for 100 days. If I run this model, I can plot the event count, how many events occurred. And here's a plot of the event count. And you can see, well, 9 events occurred. Well, we should have had 5, on average, we'd had 5 events occur. And if we ran multiple realizations, we'd see that. But on this particular realization, we had 9 events occur. Let's look at the table. And the table says, well, the first event occurred at 5 days, and then there was another one at 7 days, and then there was another one at 3 days. But that's not really what happened. The first event occurred sometime between 4 and 5 days, but we just recorded it. No events had occurred by 4 days. By 5 days, oh yeah, 1 event occurred. It does not mean the event occurred at 5 days. It means at 5 days, 1 event has occurred. This is an instantaneous value we're looking at. It says, what's the event count at 5 days? It's 1. All we can infer from that is the event occurred sometime between 4 and 5 days. But we can actually see exactly when the event occurred. If we go up here to our simulation settings and press the advanced button, and we can tell GoldSim to include unscheduled updates. We refer to these as high resolution results in scalar time histories. So the key point here is, when you do this, GoldSim only allows you to do it for scalars. You can't, it will not save unscheduled updates for arrays. So I'm going to click that. And you notice, by the way, whenever you change something in the advanced settings of the time dialog, it's going to put a little checkbox here. So this tells you that we're not at our defaults anymore. If we were at our default values, this would be cleared. So that kind of gives you a hint that I've changed something behind the scenes here. If I now run this model and I look at my event count, we're going to get a different table completely. So here, we're only plotting things when we have to plot them, when something has changed. So it says, well, I was 0 at 4 days, I was still 0 at 0 days, I was still 0 at 4 days. An event occurred at 4.077 days. Boom. It's another event occurred at 6.315 days, and another event occurred at 10.429 days. So you can see we're inserting events here, right? In order to actually plot this, we don't actually have to save every time point. We only have to save the time point right before something changed, right? So we're being a little clever here. We're saying I'm only going to save time points right before something's changed. And so our plot actually looks similar, but if you were to zoom in, you would notice that these events, occurred. This one occurred at 25.449 days. We're actually capturing when it occurs. So that's a really trivial example. Let's look at a little bit more complicated one. This is a model of a pond in which we have a volume, an initial volume, and we have a constant inflow into the pond. And we have some upper bound. We set an upper bound of 35,000 cubic meters for the pond. So let's just look at this model. We're going to run it for 50 days with a 1-day time step. So if we run this model, what we're going to see here, let's look at the chart first. We hit an upper bound. We hit our upper bound, and we immediately started to overflow, right? When did we hit the upper bound? Well, according to this table, it says that 34 days, our overflow rate was 1,000. And our volume was 35,000. Recall the 35,000 was the upper bound. And by the way, I routed the overflow to another reservoir here, so I'm keeping track of the cumulative amount of water in this case that's overflowed. So at 34 days, it says 200 cubic meters of water has overflowed. Well, so what does that mean? At 35 days, it's 1,200. At 36 days, it's 2,200. So this should immediately tell you something. This did not start to overflow at 34 days, right? It says the overflow rate was 1,000, but the cumulative overflow at 34 days was 200. We didn't overflow 200 cubic meters instantaneously. What happened was sometime between 33 and 34 days, the pond started to overflow. GoldSim knew that. There was an inserted time step here. We're just not seeing it. But the results of that inserted time step are certainly apparent. Oh yeah, 200. Basically, you should be able to infer from this that the event occurred at 33.8 days. We hit the upper bound at 33.8 days, at which time we started to overflow. At 33 days, the overflow rate was 0. We weren't overflowing yet. At 34 days, we were overflowing at a rate of 1,000 cubic meters per day. At 34 days, at that exact time, that's the cumulative amount we've overflown so far. So to see that, let's again go back and let's turn on our unscheduled updates. And now if we run this model again and plot that result, again, we're now going to see what's happening here. Yes, at 33.8 days, we hit the upper bound. The cumulative overflow at 33.8 days was 0. We haven't overflowed anything. We just started to overflow. The overflow rate was 1,000. So the overflow rate was 1,000 for 0.2 days. So by 34, we had overflown. We overflowed 200 cubic meters. Now let's look at a little bit trickier example. Similar model. The model here is exactly what I've just run before, but the difference is I'm going to turn off the inflow rate. In particular, my inflow is going to be 1,000 cubic meters as long as E time is less than 34 days. If E time is greater than or equal to 34 days, we're not going to overflow anymore. So we're going to get a bit of a confusing result here. So if we run this model and plot the result, let's look at the chart first. We started to overflow, but you'll notice there's no overflow rate. We hit the upper bound and there's no overflow rate. But there's a little bit of cumulative overflow. What's going on here? Let's kind of zoom down. And you can see at 33 days, there's no cumulative overflow, there's no overflow rate. At 34 days, we've got 200 cubic meters that has overflowed. But the overflow rate is 0. In fact, it's always 0. And people will ask us, well, wait a second, how can I have cumulative overflow if the overflow rate is 0? Well, the overflow rate was 0 at 33 days. The overflow rate was 0 at 34 days. Why? Because we turned off the inflow. It doesn't mean that the overflow rate was 0 between 33 and 34 days. You're just not seeing it because the overflow rate is the instantaneous rate at that time. We're seeing the effects of it right here. This tells you, oh yeah, we are overflowing somewhere between 33 and 34 days. And again, we can see exactly what happens if we turn this on, just to see, to kind of understand what's going on with that overflow rate. And now we see what really happened. At 33.8 days, we started overflowing at 1,000 cubic meters per day. At 34 days, our cumulative overflow was 200. Our overflow rate is 0 because we turned off the inflow. and it just remained 0, and our volume remained constant over that time. So what does all this mean? How do we interpret all this? Here's what you've got to keep in mind. So people ask us, the little example I just shown you here is a very common thing that people will run into and say, I don't understand this. Why is the rate GoldSim is outputting different than my spreadsheet, for example? You know, I've exported these overflow rates that GoldSim is calculating to a spreadsheet, and they don't add up to the amount that GoldSim says that's overflowed. What's going on? Mass is not being conserved. Well, look, here's the issue. The value of any output in a GoldSim model represents the instantaneous value at that point in time. It does not represent an average value. It's the overflow rate at 34 days. It doesn't mean it's the overflow rate between 33 and 34 days. It's an instantaneous value. And this puzzles people, but it shouldn't. Clearly, other variables in GoldSim, such as a volume, they represent instantaneous values. If you look at a plot of the volume, you'd never interpret that to mean this is the average volume over the time step. No, you say that's the volume at that point in time. Why should we think that rates are treated any differently? It's just another variable in GoldSim. GoldSim is outputting a variable at that point in time. It's a mistake to ever think that it's of average value. Unless we've done some things to tell GoldSim to calculate an average value, which we'll talk about at the end, it's an instantaneous value. Another reason that these unscheduled updates can cause confusion is people say, you know, in my model, I sometimes refer directly to the time step, X times 1 day. And it's not behaving like that. Well, it's not behaving like that because you're assuming your time step is 1 day. Your time step isn't 1 day. You've specified a 1-day time step, but you should never assume that your time step length is constant. It might actually be shorter because we've inserted unscheduled updates. In fact, as a general rule, you should rarely, if ever, reference the time step length in your model. If you think about it, the time step length is just an artifact of the numerical solution method. There's no physical meaning to your time step length. We have to specify one to tell GoldSim when to do its calculation, but it doesn't have a physical meaning. So in general, you should not be referencing a time step in your equations. There are some very rare instances where sometimes you must, right? But the big difference here is when you must reference a time step, all right? Use the GoldSim run property called timestep length. The timestep length represents the time since the previous update. And let me just show you an example of that. We'll go back to one of our overflow models. So here's our original overflow model. But what I'm also doing here is I'm recording the time step. I've just created up a variable here called time step length. And the time step length, by the way, is a run property. It's right here, right? So I'm just saying, report to me the time step length, and I'm outputting it here. And if I run this model, and I'm not saving unscheduled updates, now you can actually see what GoldSim's doing. So here you can see at 33 days, there was no cumulative overflow, there was no overflow rate. At 34 days, we had an overflow of 200 cubic meters. The overflow rate was 200. And the time step, remember, it refers to the time since the previous time I updated the model was 0.2. So this is telling you, oh yeah, I updated the model at 33.8 days. So the time step length, remember the time step length refers to the length of the previous time step. So if you know that you can use this time step length, in situations where you must use, for some reason, reference a time step, use that property and you'll be okay. Now, why do we have confusion regarding this issue? We scratched our heads about it many times, and I'm convinced the reason we have it is it's because that's how spreadsheets work. So in a spreadsheet, the time step is fixed. You don't track flows of material in a spreadsheet. You don't track flow rates. You don't calculate flow rates. What you calculate is a volume over some fixed time step. You have a row for every time step, and then you have how much volume moved over that time step. It's not a rate, it's a volume. And so we're used to thinking in terms of spreadsheets, but we shouldn't build our models because of the tool that we're using. Spreadsheets don't represent rates because they can't. GoldSim is a simulation tool. It can represent rates. It can calculate rates. Let's take advantage of that. All right. The question then comes up, should I ever disable unscheduled updates? It turns out we allow you to turn these off. You can say, no, I don't want to allow any unscheduled updates in my model. And we allow that. It's okay to turn off unscheduled updates. But in general, you should avoid it. And I'll give you an example here why. One reason people tend to disable these unscheduled updates once they learn they can do it is because they've set up their model and they have assumed somewhere in their calculations there's a constant time step. In particular, there may be some part of their model where they're referring to 1 day or 1 year or 1 month. They're actually using that. Occasionally there may be a valid reason to do this. It's quite rare. Typically, this is just bad modeling practice. You should get out of doing this. As I said before, the time step is an artifact of the modeling approach. It has no physical basis. We shouldn't be referencing the time step in our model. But again, there are some occasional times when I just must do it. And it turns out that in many cases, you can in fact disable unscheduled updates and there will be no detrimental effects. Let me show you an example. In fact, the pond example that we've been working with, you can actually turn off the unscheduled updates here, right? So if I come up here is my pond example, and here I've turned off unscheduled updates. So this box right here says allowed unscheduled updates. It's checked by default. If you clear that box, GoldSim is not going to insert unscheduled updates. And remember, this guy hit an upper bound of 33.8 days. So if I run this model, we're now going to see a little bit of a different result. The actual results, how much water overflowed, are not different at all in this simple case. But you'll notice now that the overflow rate does in fact represent an average. So this actually now represents the average overflow between 33 and 34 days. GoldSim kind of does that for you, right? It says, well, I'm going to, it realized that the overflow happened at 33.8 days. It calculated things properly, right? And it just did an average value over those. So we did not have an update at 33.8 days. So in this case, we got away with it, right? GoldSim says, all right, I'll let you do that. I'm okay with that. It's not going to really change your model in this really, really simple case. But here's the problem. In some models, doing this, disabling unscheduled updates, can lead to really serious errors. In particular, if you have a model in which it's critical to know when a particular event occurred, and you might say, well, okay, give me an example. Well, here's a really classic example. And if you think about, if you have a pond, oftentimes the way you manage that pond is you have a pump in the pond, and when the water level gets to a certain point, you turn the pump on because you don't want the pond to overflow. And then once the water level drops, you turn the pump off. It's a feedback control system. It's a really common way how you'd control a water level. It's also how a thermostat works, right? You hit a certain number, you turn the pump on. When it drops down to another number, you turn the pump off. I'm going to show you an example of that in which if you disable unscheduled updates, you're going to get very different results. So let me first show you that model. And so what's going on is here's we have a pond. I've got an inflow here. I've just put in a random set of flows into this, generated some random inflows. So we have a random inflow coming into this pond. And what we've done is I've set up an upper target level and a lower target level, right? So I say I want to turn the pump on when it gets to 31-meter elevation, and I want to turn the pump off when it drops down to 29. So essentially, we're trying to manage the water level between 29 meters and 31 meters. In order to do that, I need to turn these into volumes, and I've set up a stage storage relationship such that it's just linear. So just to make this model simple, when the elevation is 31 meters, the volume of water is 310. When the elevation is 29 meters, the volume of water is 290. And the way we're doing this is I'm going to have a withdrawal rate from this pond, right? I have an outflow, and that outflow is computed. It says if the pump on, I want to pump at 200 cubic meters per day, else I pump at 0. Well, when do we turn the pump on? We're going to use a status element for that. And the way the status element works is I say by default it's off. When do I turn the pump on? And I say I want to turn the pump on when pond is greater than or equal to the upper volume. So when the volume is greater than 310 cubic meters, turn the pump on. You'll notice I've put in an at stock test here. At stock test, interrupt the clock, insert an unscheduled update when this statement becomes true. The trigger to turn the pump off is when the pond level drops below 290 cubic meters. All right. Again, this is an at stock test. It's going to interrupt the clock. So if we run that and by the way, I'm also keeping track of the peak volume here. So if we run this model and we look at that particular pond, you see the pond is kind of going up. Here's my pond level. And now we're kind of controlling the pond level between 290 and 310. Well, it doesn't actually, the pond volume actually goes above 310, right? Here it's 329, here it's 303. Why is a pond go by? In fact, let's see what the highest pond volume was. The peak pond volume was 329 in this case. Let me just try, I want to check something here, okay. It was 329. Why does it go above 310? Well, I just turned the pump on when it hit 310, but there's still water coming in, right? If I really didn't want it to go above 310, I'd probably turn the pump on earlier or pump at a higher rate. But that's the control that I have. I've turned the pump on when it hits 310. So let's just remember that number, 329. And now let's run this model. But instead of, there's two ways we can change this model. One is we can turn off unscheduled updates, and I'll do that. That's the simplest thing to do. I'm going to turn off unscheduled updates. And now if we run the model, you see our peak volume is 341. It was 329 before. Our water level went higher. We can kind of see a comparison of these guys down here. This is the model when I had unscheduled updates. This is the model when I didn't have unscheduled updates. What's happening here is we're not actually capturing our real control logic. The pump is positioned such that it turns on at 310. But in this model over here, it did not turn on with 310 because GoldSim says, well, I don't know when we're hitting 310. It's going to look until it sees the next scheduled update. At the next scheduled update, it says, oh, are we greater than 310? Oh, better turn on the pump now. But in the real world, that's not how it would work. So you're not accurately representing how your pump is positioned in this case. And therefore, you're overestimating how high the water level gets. Again, this is a simple little example, and this may not be catastrophic, but you can imagine other situations where missing something like this can really give you a drastically different type of result. So one question that comes back when we talk about unscheduled updates, people say, well, okay, I understand why you want to have unscheduled updates. I can deal with that. And I now understand GoldSim flow rates are instantaneous values. Yep, I understand that now, but I need to report daily values or monthly values. But you're telling I need to report a flow rate. I need to report a daily flow rate, right? I need to report an average daily flow rate. But you're telling me GoldSim is calculating instantaneous daily flow rates. How do I deal with that? Well, we can handle that. We handle that by using reporting periods. So let me show you a model that utilizes reporting periods. This is the same overflow model that we've been using for the entire presentation. But in this case now, when we're setting this model up, instead of having a basic time step, we have a reporting period. So I say I want to have a reporting period of 1 day. All right, so I have I could have more reporting periods, but I'm going to have a reporting period of 1 day. What does this mean? Well, when you set up a model with reporting periods, you can tell GoldSim what to do with the results. So I'm going to say I want to do reporting periods. I'm going to plot the overflow rate in 2 different ways here. I'm going to actually plot it as at the plot points. This is what GoldSim is actually calculating. But I can also tell GoldSim to plot things as average values, right? Or cumulative values. So we have a few options here. Here I'm telling GoldSim to plot the overflow rate, calculate the average value for me. So if I run this model and I look at my results, remember things happened about 30, you can see, remember things happened between, the overflow was at 33.8 days. So here we are. Here's what GoldSim was reporting at 34 days, 1,000, right? But the average value is 200. This is always, by the way, backward looking. So GoldSim says between 33 and 34 days, the average overflow rate was 200. Between 34 and 35 days, the average overflow rate was 1,000. So this is the value that you wanted. You say, I really want to plot average values. Well, all right, tell GoldSim to plot the average value and it will plot it for you. And now you can export that or do whatever you want. You can plot it on your chart. And now you have your average values. Okay, that's all I wanted to talk about today. I just want to summarize these things. Remember that the value of any output in GoldSim represents an instantaneous value. It's not an average value. In general, you should not assume that the time step length is constant. It may actually be shorter. You should rarely, if ever, reference the time step length in your model. It's just an artifact of the numerical solution method, has no physical meaning. If you must reference the time step length, use the time step length run property to do so. You can disable unscheduled updates, but there's few reasons to do so. If you need to report average flows, you can always compute these by using reporting periods. And that's all I have for today. Hopefully that was a value. If there's any questions, you guys can type in a question here. If you hold on, I do have a question here. Let me look at it. Somebody has a question that says, because it can cause challenges when they are unanticipated by the modeler, can you have a warning or allow a pop-up warning, toggle on off, to tell the user that an unscheduled update, a time step event was used? we don't do that. The one thing you can do is the most common times that unscheduled updates occur, by the way, where they cause confusion are when you have when you hit an upper or lower bound, right? Well, if you look at the run, we have our run log here, and in our run log, there's an option for a run log. It says log when a reservoir or pool element its state changes, and so this right here, if I were to click this, whenever a reservoir or pool hits the upper or lower bound, okay, we will write something to the run log for you. We'll say, oh, we hit an upper or lower bound. In fact, this is something you should do. Oftentimes, where people get confused is they'll set up some logic, let's say in a reservoir or a pool, and this logic is set up so that they're turning a pump on and off, but they're not doing it in a clean way. So they're saying turn the pump on when it hits 3 meters and turn the pump off when it drops below 3 meters. If you do that, your pump will turn on and off instantaneously forever. Boom, 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 right? Because you have to have a dead band in there. Turn it on when it hits 30 meters, turn it off when it's 29 meters, something like that. And you'll get, all of a sudden, your model will grind to a halt, right? It will go really, really slow. And that's because GoldSim is inserting all these unscheduled updates. A good way to see that is to come over here and click this on. Your run log now will be very, very long. It will show you that it's constantly interrupting the time step to show that that's happening, right? So we can record this. The idea of sending it to the run log anytime is not a bad one. We could potentially add an option here. In general, these should not be unexpected events, right? Why should they not be unexpected? The main times they occur is when you have random events. Well, if you've put in a random rate of occurrence, you should expect that there's going to be an inserted time step. If you use an at stock test, you should expect that there's going to be, in both those cases, it's never going to happen on a scheduled update. So you should expect these guys to happen. This is the one time where it's might be a little bit surprising when we hit an upper or lower bound, but you can tell GoldSim to warn me whenever that happens, and I would just click this on to be yeah, to be aware of it. Somebody has just pointed out, and this is a good point. Another time, if you ever use the financial module, you can also insert, if you, depending on the type of compounding you're doing, it will insert unscheduled updates in order to do the compounding properly. But we know when those are going to happen. If you do quarterly compounding, it'll insert them at, every quarter, for example. But yeah, these are excellent points. I think the key thing that you should be aware of is that if in terms of these unexpected unscheduled updates, if you've put in an at stock test, you're asking GoldSim to put in an unscheduled update. That's why you're doing it. If you're putting in a timed event that's random, you're asking GoldSim to put in that unscheduled updates. If you're hitting upper and lower bounds in the pool and you want to be warned about this, click this button. After you run the model, there'll be a warning and say there's 400 warning messages. You can go and look there and they'll say, oh yeah, I'm hitting upper and lower bounds. Okay, if anybody has any other questions, what I encourage you to send me an email, or you can always send a question to our to our help desk, as I may not always be around. And we're quite happy to answer these questions. So we will post this this webinar along with the models that I showed you to our website. Probably we'll have it posted maybe by tomorrow or Monday. All right, I thank you for your attention, and everybody have a great day.